Alright, you're right. For this afternoon's lesson, what I'd like you to do, hopefully if you watched the pre-learning videos, if you haven't watched the pre-learning videos, this video is a good one to watch. If you have watched the pre-learning videos, have a go at the activities, look at the examples, and then maybe come back to this video if you need to. So making sure that we're going to be able to do operations with fractions, being able to simplify and compare orders and values of fractions. So here are some extra videos apart from the preparation videos you'd found on Canvas that may be of use to you. I'm just going to jump in and we're going to get straight through to some examples. So what I want to talk about here is a couple of ways of simplifying fractions. What we have here on our calculator, hopefully we've used our calculators. If you're running the Casio version, even if you're running the slightly newer version of this, which has buttons here and it's green instead of orange, you're going to have the same functions. If you're running a slightly different version of the calculator, you're still going to be able to do something very similar. The buttons may just not be exactly the same as mine. So running through this 12 over 90, I'm just going to type on my calculator 12 over 90. I'm going to press equals, and my calculator is going to simplify it for me straight away to 2 over 15. And that's one way we can simplify fractions, is just to use our calculator. But what happens if we've been asked to do it without our calculator? So what I want to bring back to your memory is something we did the other lesson. Remember when we did factor trees? And I asked you to think of a number, you thought of 12, and you said 12 can become 4 and can become 3. And then 4 is 2, and is 3. So you told me 12 equals 2 squared times 3. We did that the other lesson when we talked about factor trees. And so what we're going to look at is simplifying fractions using this idea. So remembering we can press 12 on our calculator. And above this button here, the degrees, minutes, second button written in yellow is this thing called fact. So I'm going to go Shift, Fact, and you can see it says 12 is 2 squared times 3. Exactly what we figured out. So 12 is 2 squared times 3, and 2 squared times 3 is just 2 times 2 times 3. 90, when we do it on our calculator, so 90 equals Shift, Fact. We can see it's 2 times 3 squared times 5. 2 times 3 squared times 5, which equals 2 times 3 times 3 times 5. Now I'm going to grab my highlighter out here. Remember we talked about when we were simplifying fractions, that idea of dividing out or cancelling out numbers where possible. If I have a single 2 in the top, I can divide it out or cancel it out with a single 2 at the bottom. Now you can see next door I have another 2, but there isn't another 2 in the bottom to cancel out with. So it just stays put. I have a 3 in the top and I have a single 3 in the bottom. And then that's it. So notice how in top and bottom I have 2 and 3, 2 and 3. So what we say is our highest common factor is 6. Of course 6 was just 2 times 3. And we can see that that's the numbers we highlighted in both fractions. So now that we've highlighted them, they divide out with each other, they cancel out with each other. And what we're left with is, in the numerator, the top is just 2, and in the bottom, we're left with 3 times 5, which ends up being 2 over 15. And that's what we saw on the calculator when we first started. So just remembering that one way we can simplify fractions is to use those factor trees, getting numbers written as products of their prime factors, and then looking for, can we cancel out or divide out numbers that are exactly the same. 2 divided by 2 equals 1. So I don't need it because 1 times anything stays itself. 3 divided by 3 is going to give me a 1, so it cancels out. I don't need it. And we move on that way. Another method we can think about, if we don't have our calculator, is to use our divisibility tests. So let's think about the number 12. Let's change my colour here to purple. The number 12. Number 12 is even, so 2 can fit into 12. The number 12, 1 plus 2 is 3. So 3 fits into 12, so I can write 12 there. The number 4 fits into 12. The number 5 doesn't. Because 2 and 3 fit, 6 fits, 7 doesn't fit, 8 doesn't fit, 9 doesn't fit, and 10 doesn't fit. We know that. Now, if we look at the number 90, let's look at 90. 90 is an even number, so 2 will fit. 90, well, 9 plus 0 is 9. 3 fits into 9, so 3 will fit into 90. 4, does 4 fit into 90? Let's see, 4 fits into 9 twice with 1 left over, so 4 doesn't fit into 90. 5 fits into 90 because it ends in 0, so 5 fits into 90, so we can write that. Cause 2 and 3 also, we have another time where 2 and 3 work, so 6 is going to fit into 90. 7 won't, 8 won't, 9 fits into 90, ends in 0, so 10 fits into 90. We've gone through our divisibility tests, and let's have a look at this. The highest one that they both have in common is that number 6. So again, we say the highest common factor of the number 90, from what we've seen, 12 and 90, is the number 6. So we can use our divisibility tests. So we're going to say 12 divided by 6 and 90 divided by 6. 12 divided by 6 is 2. 90 divided by 6 is 15. If we're not sure, we can bring over here, how many times does 6 fit into 90? It fits once, with 3 left over. How many times does 6 fit into 30? 6 fits into 35 times. We have the number 15. 2, well, the number 2 doesn't fit into 15, so no need to check any further. Now, if we have these numbers here and we're not sure, we can go back and do our divisibility test to see if they fit in again. And if they don't fit in again, well, we don't divide them anymore. If you can find another number that the divisibility tests work, well, then we would continue to simplify. Moving on now from simplifying to the next easiest thing to do with fractions, which is multiplying. Now, 2 things you can do with fractions. Fractions and multiplying fractions, easiest thing in the world to do. You just do the top times the top. So you would just do, let's do this in a different color, 3 times 6. So 3 times 6, which is 18. And you would do 4 times 11, which is 44. Boom, there's our fraction. 18 over 44. However, we're mathematicians. Lazy, efficient, whatever you think. So we're not going to do that. I'm going to look, can I simplify my fractions first? Can I deal with small numbers from the very beginning? Well, going through it, remember 3 is a prime number. 4, remember, as a product of prime numbers is 2 squared. So 4 is just 2 times 2. 6 is 2 times 3. And 11 is a prime number, so it stays. Remember how I said it was just the top numbers multiplied together? 3 times 6 equals 18. Well, 18 is 3 times 2 times 3. And 44 is 2 times 2 times 11. Now, looky here. There's a 2. And there's a 2. So there's a common factor straight away. So we can divide out or cancel out that common factor of 2. And what we're left with is just 3 times 3. And 3 times 3 is 9. And 2 times 11 is 22. Now we can see from 18 over 44, we can just halve it and get there. But this trick's going to help us, or this method's going to help us if the numbers aren't as easy to see or as straightforward. So let's go over here and look at one that I've already completed for us. 12 over 20 times 60. Well, 12 is 2 times 2 times 3. 20 is 2 times 2 times 5. 60, well, the number 60 by itself has the number 1 in its denominator, but we're just lazy and we don't write it. So now let's have a look at this. I can see a 2 and a 2, a 2 and a 2. So I'm going to cancel out those common factors. Now I can remember, just multiply everything together. And when I multiply everything together, before I went on, I'm like, oh, hang on a second. There's another 5. So I can cancel out those common factors. I can divide out those common factors. And what we're getting left with is 3 times 2 times 2 times 3, or 6 times 6. So our answer is 36. So 12/20ths of 60 is just 36. So there's an example, right? And then finally, the last example for this one, we're going to look at 18 over 7 divided by 3 over 14. Now you might look at that and go, oh, ugly numbers, and I agree. So I've already done this on our calculator. I've gone 18 fact, and just to prove it, 18 equals shift fact. 18 fact is 2 times 3 squared. 7 is for these numbers. Now the other thing, if you watched the video earlier, remember that divide, it's the second easiest thing, and we keep the first fraction. So we're going to keep 18 over 7. We're going to change our divide to times, and we're going to flip our last fraction, 14 over 3. And when we do that, 18 I said was 2 times 3 times 3. 14 was 2 times 2. Look at that. There's a 3 and a 3. I can divide out that common factor. There's a 7 and a 7. I can divide out that common factor. Now there's nothing left here in the bottom. I've cancelled everything out. But remember, I didn't cancel things. They divided. 7 divided by 7 was 1. 3 divided by 3 is 1. So there is actually a 1 written there at the bottom. But I'm a lazy mathematician. If I don't need to write it, I'm not going to write it. So that's why you can see my final fraction became 12 over 1. And again, lazy. Do I need to write 12 divided by 1? No, so we just write it as 12.